So the next topic is we are having it as battery structure. We are for any kind of and some semantics if you are speaking of programming. So same case here also when we are going for follow okay. So how your structure is going to be coming out. So when you are going to whatever the things that are not needed for the users, that things you need to omit out. So when you are capturing or when you are taking the required information, then your structure is going to be efficient. So here also for the same case, that is for the same thing, we are having battery. So what the battery is going to do or what is a battery structure is going to give us or what are the various types that are associated with batteries, let us see right now. Okay. So the battery is a data structure that allows very efficient processing. So pre-processing. So what you will do in pre-processing? What is data pre-processing or pre-processing? What we are going to do in pre-processing? Pre-processing. Data mining subject is finished. Data mining or introduction to data mining subject is completed. Not completed. So have you ever met this topic called data pre-processing or pre-processing? In any subject you got the topic as data pre-processing or pre-processing. So where you got data pre-processing, machine learning you got very good. So what are the specific subject according to how many collection or cleaning, data cleaning, data collection. Okay, next data collection, data cleaning. Next, third data antundiramma. Next, data. So first one is data collection. You said that is next. అమ్మా అంతేనా రెండేనా సో హ్యావ్ యూ ఎవర్ రెడ్ అబౌట్ data reduction pre-processing. So according to you, it is having six. So what we are having is data pre-processing. We used to have data collection, data cleaning, data integration, data reduction, data integration, data transformation, and data digitalization. These six steps altogether will be having as 5 steps. So knowledge steps, that is knowledge discovery, database or knowledge discovery data. Okay. So these steps are we are going to call as process steps. So that is whatever the text or the information related to uh, tree right? So if you want to go for a particular data structure, if you want to go for a structure, first you need to find entire information related to that particular data structure. Okay. So then after collecting the information, that is when you are giving a query, you will be getting entire information. So among which you will be having related data and not related data as well, right? What is going to do for us? What is going to do is when you are giving a query to the search engine or your storage system, what is your output when you are searching for a topic? In general, when you are some operating system or software engineering or information system, what is your okay. So here also in data structure which we want to plan it as for a factory as factory. So so we are going to we are going to information. Tell the information. What is the information? Required data only going to collect. So how going to collect data? Okay. We are going to take formatting or simply going to make it as separate file. So we will be making separate file. Then we are going to entering file as a single of that. You want to get the going to delete that process entire information and you are separating your required information as 1, 2, 3, 4, arrangement document. They will be integrating all the document format as dictionary and will be doing this process. You're going to take it as or you are going to okay. So first you are going to collect data, that is you are going to give your information, that is whatever the data set or whatever the data set you want to collect the information. Then you are going to give it to the then you are going to make a structure. Okay. So that process we are going to take it as or that process we are going to name it as the pre-processing. Okay. Data collection, data uh, data 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 these steps we are going to take. So this section that is this program is going to give us the this particular pattern. So this structure was originally described by Gonet in paper. So called as our matrix of data structures. are taking it from the paper or research title called as unstructured data structures, which was written in the year 1985. It was perfect. As of now, it was reprinted in the year of 1985. Okay. So later used in conjunction with the computerization in Oxford English Dictionary. So what we are reading it as separate files. Dictionary but it is computerized Oxford English Dictionary. Right. From A to Z, we are having the text. So because of the implementation, system has become well known right now as a software. Okay. So as it became very fast, as it became very famous, coming to know or we came to know about this particular fact. So how we are going to search? So simply we are going to take or we are going to have the entire information, right? So if you are writing some text, so if you are writing some text, that particular text is divided into parts. Those parts we are going to take it as strings or substrings, right? So again in substrings we are going to search each and every character. Okay, so that is what we are having in semi having text or words. So say for example, so your department is data science. We are having it as a complete word. Right. So how many words having as a whole? How many words we are having as a whole? Four different words we are having. So again, in first word, we are having how many characters we are having in artificial? Six characters we are having. So how many data for 7 letters. Right. So this complete as for separate strings, we are having a string and a single string, right? So what we are going to do, we are going to take each and every letter of each and every word, and then we are going to go for the structure making. Okay, that we will be seeing in this particular semi-infinite strings concept. Then we are going to go for the building of that particular tree. Okay. So we will use a very simple model of text. Our text or text database will consist of single or possibly long array of characters numbered sequentially from 1 onwards. That is, we are going to give the numbering from 1 to n for this particular complete string. Okay. So whether the text is already presented as such or whether it can be viewed such or not, then we are going to apply for this particular battery algorithm. So if it is then we are going to eliminate keeping it. So to apply the algorithm, it is sufficient to be viewed. So just like we have seen artificial intelligence as a we need to take the entire thing as a single array of characters. Okay. The semi-infinite string is taken given context, but going on as necessary to the right. Okay. So how we are moving from left to right. So that is artificial intelligence, A letter to last letter, data science, E. From A to E, we are moving. How we are moving? Starting from 1 to N, we are giving as the numbers from one letter to 1, 2, 3, 4, 5. 6 up to n. Okay. So whatever the size or whatever the length of the string is, we are going to start from 1. We are going to end with n. Okay. So here, as a semi-infinite string is a subsequence of characters of this array, and whatever and is the subsequence of this particular array. That is our radius. So A is one, I is one substring, C is another substring taken from the given sorting point of left to right. So that is also clear. So in case of semi-infinite string, that is we have to use the term as S I string. Semi-infinite string is indicated of SI string. Okay. So is beyond actual text, special character to be added, edit for like space are also to be considered this particular case when we are going to draw for the string. Okay. Will be considered added edit. So when we add after n plus one n plus two n count okay. So if our complete exercise is some 4 and 7, so what is the total? What is the total? 7 is 4 and 7, 11, 19 plus 4, 30. So is 3 space. So the length of particular data set is completely is having 36, 30 as artificial intelligence is having, sorry, artificial is having 7. Okay. So the name semi-infinity is taken from the RC with semi-infinite lines, lines with one origin. Okay. So semi-infinite in the sense, so lines with one origin we are going to. So in this case, so the text is once upon a time in a far away land. What is our starting line? That is, what is our starting point? Oh, that is once upon in a far away land. So in this case, our starting point is O. Okay. So however, substring is going to be taken. The name infinity is taking that is taken analogy from geometry where we have semi-infinite lines. Okay. So you are starting from here, you will be ending up at so what is the starting line? What is the starting line? Or what is the starting point? Once. In this case, you are using it as once. Okay. So our text is going from the first center and nth word. Okay. So in between you can keep commas or in between you can keep special gas and you take your text to the nth level. Okay. Lines with one origin, but in one direction. So it has to be one direction. That is, if you are starting from once, has to stay line. If you are using is going or it is taking. So once upon a time, okay, that is we are going to write the test fill, we are going to fill. So the text. Once you are keeping or once you are hitting on enter, then your text is moving to the next line and then it is becoming another substring, SI string. Okay. So SI strings are uniquely identified in position where they start and for a given fixed text, this is simply given by identity. So if you're having a fixed text, so what is the have dot dot our length. So in this case, can you guess what is the length of this? Can you guess what is the string? So where dot dot indicates, you can write what is the next. What is the length of that particular string? Can we define? So when you are keeping dot dot dot, you can write whatever the text you want to write, or whatever the text you want to add, you can add, right? So here we right. So for example, text we are taking it as one land. So again, it's string two. What we are going to do, we are going to take away the first character as we have visited, and then we are going to write it from the second character to the declared. Okay. So in the third string, what is my next sentence? It is starting from CE to dot dot. So in substring 4, what is the length? So string 1, I am starting from once upon a time. 2, I am starting from NCE. String 3, where should I be? Upon a time. String 4, E upon a time. String 5, string 5, U time. 6, ON a time. So what is the difference according to us and according to this given text? Where we have went wrong? So according to our procedure, we came across once upon a time NCE, CE, next E, right? So what the system has taken and where we have gone wrong? Mistake ఎక్కడ జరిగింది? In eighth sentence or in eighth string we got special character, or what is the character system? String, and it taken from space also we got string, that is sub infinite string we got. Okay, the special characters are also going to be considered when you are going to draw. That also we have discussed. Okay, so now come again, same answer. So for first string we are going to take second NCE, third CE, fourth E, fifth one space upon a time. Next 6 U upon a time. 7 P upon a time. 8 is on a time in a for. Are we getting correctly? Right. So similarly, when you are going to draw, or when you are going to go for the remaining also, it is going to be the same case. Okay. So eighth character we are getting it as on a time. So 9 and 10, O and N, they have gone. 9 and 10 they have gone. Space, here you are having space, and 11th is headings. Next, when you are going to check, be getting the same case as our answer. Okay. The substrings. So it starts from one end and it should reach till the last. In between, you can keep how many number of paths you can keep. Is the entire document, then it is becoming. Then this strings formally as abstract data types and any important model of text for the purpose of the most of important operations of substring is lexicographical comparison of substrings and will be only one defined. That is only starting letter and remaining text we are writing as a whole. Okay. So this comparison is one of the resulting for comparing two strings contents that is not their positions. So we are comparing two strings but not their positions over here. Okay. So note that unless we are comparing a substring to itself, the comparison of strings cannot yield identity. So unless you are going to compare the same string or the same substrings, you are not going to get the same value or same kind of things. So you are going to get two different or two identical values only, unless you are going to compare same string. That is, if you want to compare AIDS and AIDS, what you are going to get? A, D, D, S, S. You'll be getting entire words as common. Okay. So when you are comparing two different cases, that is artificial intelligence and one subordinate and comparing these two and these two different unique letters. You are comparing, you will be getting identical letters. When you compare unique letters. Okay. So for example, the above strings will uh, compare as follows. That is, so whatever the strings that we have seen in the above example, so what were the letters that we have taken? So 22, 1, 2, 8, 11. So of the first 22 strings, the lowest string is time. So how you are getting these? Again, you are getting these when you are converting your given text into the format of your dictionary, again the terminology is going to be changed, and what is the length is going to be, it is not going to be changed, because whatever the text or whatever the words we are having, the same length or less length only we are going to get, but we are not going to get the higher values. Okay. So then we will be covering with our pad trees. Okay. See, so here we are having a pad tree or patrika tree. So how we are going to get this pad tree or patrika tree? So from where we have taken information or from where we got this particular information, let us see. A pad tree is a tree, so which is from 1973. So which was taken with the help of Clark and Sedgwick. So these scientists are research with the help of Burnett constructed over six produce a pattern individual bits of, you know, in the form of digital tree. So where you are going to decide which tree, which node is going to be coming first and which node is going to be coming. That is, which is going to be, is going to be a whatever producing system. Okay. Category is a digital tree where the individual bits of keys are used to so will cause a balance right stopping. Okay. Trees of digital trees. once you are having left side, once you are having the value as 1, it's going to appear towards your root node. So in root you will be having left side 0 values, right side you will be getting it as 1. Okay. Patrika trees have each internal node it may be given by an absolute rate of its okay. Therefore, two things. So go with the very you can go with the single descendants to be created applying this particular thing, it is going to and it is going to give us the required documents or required. Both the subtrees are non-null. So Patrika trees are very similar to compact substance trees. Position data. In our case. So let me give an example. So for a text size of of n, so text size we are taking it as n, right? So there are n external nodes in pad tree and n minus 1 internal nodes. So node size is n we are getting and length we are getting it as that is we are getting it as n minus 1 nodes. So this makes a tree of order n. So in size, which relatively small store some then can go for adding more. Okay. So here we are having a text that is 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 1. Okay. So this is our text and this is our position. So first having what value is root is having root is value according to the example. So this is text having 0, 0, 1, 0, 1, 0, 1. So what is the root node is contained values. Don't check for the position. Position is first position you are having it as 0 value. Next, second position. What you are having it as second position? 1. So it is going to be towards left side or towards right side. When you are your tree must be towards right side or towards left side. Towards left side. Right side. Okay. You are having 1 and 1. When you are having it right side. Next, again 1 you are having. Where you will be keeping them? You will be keeping as left side is empty. Then 0 you are having. Then 0 you are having. We are going to take 0. Left of 1, left of 1. Left of 2 or left of 1. Left side of 2. Next, again you are having 0. So do we no, will be next node you are having it as 1. So you are going to keep the particular node as 2 is complete. which side? Right side of your this part, and you will be keeping and updating your value as 4, and then again you will be keeping on going, that is, if you are having you are keeping it towards right side. If you are having 0, you are keeping the values towards left side, and this position text you will be having and positions you will be having in a horizontal. So this is what we are having in the pad tree structure and pad trees. Okay. So figure 1 shows an example of sequence of sequence of characters. Okay. So just for the purpose of making example, in this example we show say first statements have nodes or indicate text variants reference to subscripts the contain displacement. Okay. So it is a string statement of bit to be inspected rather than this. We are going to take the complete values with the help of our text and the positions. So we have not given any splitting values, or we have not kept any values. Okay. So again, we will be having it as what the points for our pad tree. So what are these indexing points are? So whatever the count or whatever the numbers that we are going to get is our indexing point, or whatever our indexing points. Okay. So we have assumed the position of text and index. So we have nodes, position in the text. So some kinds of points are necessary or index. So most of the cases you are going to assign your positions and your text, but in some of the cases these text or positions are also going to be not required for the users. Okay. So for example, if you are interested in word and phrase searches, then only those things which are beginning of the word, right, words are going to be necessary. So when you are searching for words, that is A and ES, when you are searching that particular case, you will be concentrating on only characters A, I, D, S, like that you will be not overcoming particular values. And will be trade off between side of what is side is going to be taken is that has to be finalized and that has to be taken by the user with the help of that particular string and substring. Okay. String, substring, patrika tree, patrika. What is clear? Patraxter. is clear or still anything is to be added? So let's go forward. Right, Rama? New indices for phase structures that we are having. What are the methods that we are having? How many types we are having? How many we are having? Three types. Lexicographical indexes. Next, classification, sorry, clustering techniques, and then indices based on your hashing. Okay. Lexicographical, next clustering, and hashing. Next, battery structure. What is battery structure? What is the structure of battery? Battery structure. First sentence lo ade. So what is the use of your first structure? That is battery structure. దేనికోసం యూజ్ చేస్తున్నారు? So it is a data structure. So what are the steps in building processing? Data collection, data cleaning, data integration, data reduction. So we will try to keep all these in order. First is data collection, then you have to go for data cleaning. So after data cleaning, you have to go for data collection. Then after transformation, you have to go for integration. That is the fourth step. Last one is data reduction and discretization. Okay, data reduction and discretization. These are the 5 steps that we are going to take in data pre-processing. We are going to collect the data. We are going to think that is whatever the bugs or anything is missing. It means then you are going to fix manually or automatically. So if that is going to be done, then you are going to transform it into an understandable one. Then again you are going to make it as integration. That is n number of lines or n number of documents you are making, you are integrating it into single document, and then you are going for your data reduction and discretization. Okay. So that is coming in the pre-processing. Then what is the what is the when you are asked to write when you are asked to write this syntax, so we need to go with the starting point and we need to go with the ending point. So it is going to be starting in semi-infinite strings. So starting location and one to Bob, when you are studying your text and content, type enter. Can you keep full stop and type enter? Can you enter? So once you are typing enter or hitting enter, it is coming to the your next line, and it is becoming as finite line. Then other substrings are going to be, that is left tree, that is left node and right node. Are going to insert your left node. How you insert your left node, we are going to node. We are going to insert your left side. We are going to right side. If your value is 1, we are going to insert your value right side of your root node. So if your value is 0, left side of your root node, you are going to insert your text, insert your that. So is it yes for so it indicates that the first or one of the topic is finished. So if it is interprets, then it is clear. So it is clear. So you can write your unit 3. It is for pat text colon pat trees and pat arrays. So you can so under that you have to keep the heading as introduction, then write text searching methods, text searching methods. Lexicographical indices, lexicographical indices within brackets, indices that are sorted, indices that are sorted. indices, indices, indices based on hashing. Indices based on hashing. Indices build an index. Our aim is to build an index. Our aim is to build an index for the text of size, for the text of size, for the text of size, similar to for the text of size or smaller than the text, similar to or smaller than the text. Text, the traditional the traditional model of text used in used in, used in information retrieval of is that of that of a set of documents, a set of documents, full stop. Each document, each with optional relevance, with optional relevance, weights associated with optional relevant weights associated. Part structure. Madam, the part tree is a data structure. 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 Full stop. This structure was sorry. This structure was originally described structure was described by Bonnet, described by Bonnet in the paper, in the paper, unstructured databases, unstructured database, unstructured database, 1980. That was first of 1985. It was implemented in 1985. It was implemented and later used and later used in conjunction with computerization computerization of the Oxford computerization of the Oxford English Dictionary of English Dictionary within brackets OED Oxford because of implementation because of the implementation because of the implementation comma the PAT system has the PAT system because of the implementation comma the PAT system comma has become alone in its own right, alone its right comma as a software package as a software package for very fast string very fast string baseline again semi-five strings so kept setting as the practice as లేదు మీరు point point పెట్టేసి రాయండి semi infinite strings you wrote ఎలా రాస్తున్నారా నంబర్స్ వస్తున్నారా one is for two is for practice అలా చేస్తారా so if you are given 1.2 now it will become 2.1 so if you are not given any number just write 0.1 semi infinite strings headings will use we will use a very simple model of text. We will use a very simple model of text to represent to represent or full stop. Our text our text or text database, our text or text database will consist of will consist of brackets, possibly a characters, array of characters, array of characters, array of characters. ఇవ్వాలి 1 sequentially from 1 onwards. One to n. Whether the text is already presented, whether the text is already present as such, whether the text is already presented as such, or whether it can be viewed as whether it can be viewed as such as such as not relevant. To apply the Patry algorithm, it is sufficient to apply the Patry algorithm. It is sufficient to be able to view, to be able to view, to be able to view the entire text, the entire text as an array of characters. Entire text as an array of next line. String is a semi-infinite subsequence of characters, subsequence of characters from this array, from the array, comma, taken from a given starting point, taken from a given starting point, but going on, but going on as necessary to be left on the left side. So your thing should go on towards right side. Start from towards right. In case the semi-structured, sorry, the semi-infinite string in case the semi-infinite SI is, is used beyond the end of is used beyond the end of is used beyond the end of the actual text, beyond the end of the actual text, comma, special null characters will be considered. Special null characters, special null characters will be considered and it's to be added at its end, to be added at its end. These characters being these characters being these characters being different than any other, these characters being different in the text, any other in the text. The name is the analogy from the analogy geometry from the analogy with geometry where we have we have direction, one direction, lines with one origin, comma, intersecting one direction. Things are uniquely identified by the position where they start, where they start, and for a given fixed text, and for a given fixed text, line lo keep the heading as example and try to copy this one. Last persons, can you able to see this? Okay. Now it is visible. Okay, first write this one, that is text. Once upon a time, comma, in a far away land, dot 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 you write. So SI string 1 you write, SI string 2 also you write. Up to 8 you have to write all the strings. Then write the eighth one. Then write 9 and 10 to 11. So after writing up to 11, you can directly take your 26. Okay. So first write SI string 1, then write SI string 2, write arrays, then write 3, 4, 5, 6, 7. So you need to write all these things you have to write. What are the words or what are the characters that are eliminated and what is the remaining text that you have to write. So 5 strings you have to write. Then copy 8, then you copy 11, or copy 11, you write 20. Okay. Say finished. Tell me string 3. C upon a time. 5, 6, 7, P on a type you should write, right? Sixth one is U. Sixth one. Sixth one is P on a type. Seven. Sixth, fifth one is A. Sixth one is of type. Seventh one is P on a type. Eighth one is clear, right? So here you should speak about your space also. Special character is also be counted. Special character is also be counted in your substring. Okay. Space on a type. Your one entire space is same. Space కూడా space is also counted. పైన చూడండి the name semi infinite పైన చూడండి special null characters be considered to its end. These characters be set. Next, ninth one, ninth one, nine, ten, ten. Next, tennis, eleventh one is స్పేస్ కూడా కౌంట్ చేసుకోవాలి writing 11 directly take 22 because you know how to eliminate, how to write in infinite format. So once you are keeping instead of dot dot, once you are keeping that is not your infinite string. ఒకటే డాట్ పెట్టినారు అంటే అక్కడ స్ట్రింగ్ సెమీ the habit of keeping only one dot at the end, that is closing of your semi-infinite string. That is not your semi-infinite string. Okay. So if you are having the habit of keeping full stop, keep at least two dots, which indicates continuation. ఉంటుంది కదా ఒకటే డాట్ పెట్టేసి ఆపేస్తాము అది అట్లే కంటిన్యూ అని చెప్పేసి అనుకుంటారు సో డోంట్ కీప్ లైక్ దట్ కీప్ at least two dots so that the text is going to be continued. So you are keeping one dot which indicates the closing of that sentence which does not fall under semi-infinite string. Up to 22 it is done. These abstract characters represent useful important modal. Then write one point, this point, that is comparison is one. This point you write. This comparison is the one resulting from comparing two substrings or contents. This point you can make a note. So which indicates if you are comparing two strings, you are not going to get identical or unique characters. If you are going to compare two different things, that is two different characters, then only you are going to get unique value. Comparison is the one resulting from comparing two substrings or two SI strings contents. By two lines like that. Here it is. finished. Up to here it is finished. Up to comparison. What we are doing again, taking or we are considering once upon a time, comma, in a far away land, the same text we are taking, same string we are taking. So how we are taking, we are making it as how we are making it form of alphabetical. So when you are comparing, we are going for yes, I think for your phone, you are writing it in the form of alphabetical. And okay, visible to the okay. Pipe in the so once it is done, you keep this editing as pat tree. Okay. Keep the heading as pat tree. Bus editing is patty. Okay. SI of a text. Full stop. A Patricia's tree is a Patricia tree is a digital tree. A Patricia tree is a digital tree where 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 individual bits where this of the keys are where individual bits are used will cause a 0 bit will cause will will left something a 1 bit will 1 bit also in addition in addition load Patricia trees have each internal load an indication of an indication of which bit of the query is an indication of which bit of the query is which bit of the query is which bit of the query is to be used to be used to be used for branching to be used for branching to be used for branching. Stop. An absolute bit position, an absolute bit position, or by a count of the number of or by the by a count of the number of bits the number of bits to skip the number of bits to skip. Full stop. Next line. This allows this allows this allows in years. Descendants to be eliminated, to be eliminated, to be eliminated, and and this all internal loads and this internal loads and these all internal loads of the tree produce of the tree produce of the tree produce a useful branching. That is that is both subtrees are non-null. Both subtrees are non-null or not. Both subtrees are non-null or not. In the last point, similar to suffix trees or complex suffix trees. After knowledge, yes, I get that. Then the last point, okay. So what trees are very similar to compact suffix trees or compact suffix trees or trees. Finished. You are ready to write the example, right? In, in external loads, there are n external nodes in the pad tree, in the pad tree, and and n minus one, n minus one. As what is the size? Order of So what are, how many elements are there? N elements are there. What are the internal node size? N minus 1. So when you are going on, what is the n times you have to iterate, right? So this size is order of n. The try, sorry, which this makes this tree order of number of size. So we will want, we want to use, sorry, later want to store, later we want to store some additional information. Later we want to store, but this information will always be of a constant size, of a constant size. So you could able to see the text. You could able to see the text. 01100 100 100 You could able to see the text. Last లో కనబడుతుందా? This is the you could able to see. So this one you write it as. So this is what is text is. This is what is the position which particular node, that is left string, right string. Okay. పర్లేదు. నాన్న by at the end of the session I want the complete notes. Okay. మళ్ళీ రావాలి. రాసి నోట్స్ మళ్ళీ నాకు కాపీకి రావాలి కంపల్సరీ. ఓకే. లేదు అంటే ఇక్కడ తెలుసు కదా ఆల్రెడీ. yeah. So you keep so one topic, let us to your brains. Okay. So if nothing is added, suddenly, remember what మనం ఏం నేర్చుకున్నామో మళ్ళీ అదే ఉంటుంది. మళ్ళీ ఇవన్నీ catch చేస్తున్నాం. Right? So again, the concepts, unit 1, what is there? Unit 2, what is there as a syllabus? Unit 3 and unit 4, right? So then we are having the concept called packed arrays and factories as the introduction of in our unit part 1, unit 3, first point, right? So here we have introduced or we have given the factories and packed arrays. So our to read or to understand what is some concept or we have already read text indexing. Experiencing. Is it the first time that we are reading or we have already covered the unit 2? Experiencing is it instead of read over there as document indexing or important facts. Okay, so here we are in right. So we are going to read text indexing and for the so first right. So then we have seen the that is then it is the batteries and concepts. Then we will be seeing then we are going to see the algorithms for factories and arrays. Then we will be seeing building and searching techniques. Then comparison with other indices. Then summary and future hope. So these are the topics which we are going to cover. So far we have covered the first one, second, third one. Up to 3 concepts we have covered and remaining 4 concepts we are going to cover. Okay. So coming to the first one, So what is text indexing? So text indexing is creating data structures to enable fast text searching. With the previous related to documents, with related to so that so how many equations in the chronological order into A to Z according to our English dictionary. According to we are going to create what with help of your keywords you are going to search your index. Keywords or keywords you are going to see over here. So especially for so if you are searching words or it might be in some case, might be easy for searching a keyword or for searching a document. So if it is crossing the limit, that is maybe 10,000 or 20,000 or beyond our, beyond our expectation, you are going to a keyword which is able to, which is easy for you to search for the particular document. So in that case, you are going for text index. Okay. So by first we are going to go for the arranging, you are going to go for searching. So types of indexing methods include your lexicographical sorted the previous dictionary. According to previous class is dictionary, where you are going to have your chronological orders. Okay. So the first one is lexicographical indices for sorted. Second one is classical index. So these are the types of methods you will see in the text format as well. In internet, you see these three, right? So it focuses on our pad trees and pad arrays so far. Okay. So then coming to the importance of efficiency, that is what we mean by efficiency. So large databases, right? So need for access for smaller when you are equal to is okay. So for the databases, we are going to use searching. That is test indices and index. So why? So it is giving us two different goals. We are having two different goals. Fast search performance. We are using text index or keyword. Your searching is fast. What searching as a general. Okay. Keyword gaani meeku similar word text, then your documents are found very easily. Okay. So that is the main motive. So when using the entire document is your so as you are having large database storage, so it is going to use minimal storage when you are having with your indexing. Okay. Right. So in traditional text models, what it is happening, text has a set of documents that whatever we have seen in our embedded files. So each document assigned keywords with relevant. So each word, whatever the words that you are getting in all the documents you are writing, and then indexing. Sorry, how many times that you are indicating each and every document, right? So what is happening with the document writing and sample document delivery? So what we are following key search based we are not following. So simply as we are going with the word based approach, so require text search. So that is there is to be written, it has to be already available. So when you are uh, other side of your text searching, dynamically you can enter your text, dynamically you can go for keywords, dynamically you can go for your searching. Dynamic nature is available in searching and sorting over there, but in traditional ways it is not approach, sorry, in traditional ways it is not possible for the users because it is already pre, and what is to be not there, it is already being defined by the user. Okay. Right. So Patricia trees over semi-finite strings. Okay. So suffix arrays for lexicographical ordering. So new model is text as single long character array. So ఎలా ఉంటుంది patries అనేది structure. When it is coming for the model, text is there. As single sentence it is there. It will add long text will be there. But so when writing it as three different or you will be having the extensions. You will be having your extensions. Once you stop the same instance. Okay. So your text or word structure in Patricia trees. Okay. So here it is. So what are your Patricia trees? Patricia trees are binary digital trees which are having just like one, zero, right? So it is by digital trees. Which is having your so the size is right. So semi-infinite strings. What are these semi-infinite strings? Starting from left side and which are going to be heading towards the right side. So it won't be having any end. It won't be but no line. No line. This thing is going to be okay. So here, if you are going to take once upon a time, so string one is one upon a time. So is upon a time, like that we are having up to the 22nd string we are having as our example. So here coming to lexicographical, so exercise strings based on the not based on text you need to not based on your compare based on your text. Whatever the text that you are having, compare based on text position. So you need compare same positions when you are having no similarities. If you are having similarities, you will be having same positions, same strings, everything will be same. So examples, if I get once upon a time. Okay. So pat tree structure is again we are having 0 is left side, 1 bit is right side, internal store bit position for branching ఉంటుంది. eliminates single descendant nodes. Just in the graph. So example, the same example 0 double 1 double 0 1 double 0 1 0 double 1. So SI strings will be bit displacement is there. So the diagram is we have seen, sorry, we have taken in our notes. Okay, diagram ఇక్కడ పెట్టలేదు, but the same diagram it should reflect after this particular slide. So size structure is that is size is n external nodes, n nodes, size is order of n, additional information can be added or cannot add. After adding all the links, what to add. So coming to the indexing points, not positions need to be. Okay. So example, what are statistics only, what starts. So from there you can go for indexing, right? So indexing requirements we are going to check. That is how many words are there and all the things we will be searching, right? So in the class, we will try to cover the factories. So how many we are having? 6 basic on factories, that is basic searching, searching, range searching, long repetition, most frequent, regular expression. So the order might be, but we'll be reading all 6 course is containing the complete 5-unit syllabus. Give me that notes. Answer the question. Write down the question and explain. Yes, write down your question. Explain. Explain. Explain the data structures in information retrieval system. In information storage retrieval system. Examples with suitable examples. With suitable examples. With suitable examples. Also draw the figures wherever necessary. topic that you have to identify and you have to give the answer. Write the same answer. Bah. టైం ఉందిరమ్మా. They read the answer for the question. Still, you are having 10 more minutes time. Read the answer and try to answer the question. Okay. Try to answer at least the side ratings. Then we will wind up after your no response, no lunch, no break. First, tell me the answer for the question, at least the side ratings. Then only we will make a move towards our lunch. Otherwise, we will stay here.